Assalamualaikum warahmatullah. My name is Sabrina Binti Norafandi. My ID number 2020452982. My supervisor is Dr. Farashida Binti Muhammad Saleh. And today I would like to present my final year project 1 proposal, which is an optimization of 3D printing process parameter on printed part of PLA-HA composite materials by using design of experiment DOE. So this is the content. Introduction. So the first one is introduction. 3D printing is a technology that has been used by worldwide. One of the main causes in 3D printing that will affect the quality of the printed part is the printing process parameters. Past research has made a research on the categorization of the process parameters in 3D printing. They revised on 3D printing machine parameters and have come to the conclusion that it can be classified to three classes, which is geometry-based parameters, process-based parameters, and structural-based parameters. Katra et al. Used Taguchi approach for the optimization of the printing process parameters, which has come to the conclusion of optimum infill, layer thickness, and nozzle diameter. Go to literature review. 3D printing process parameters. Past research has stated that the parameters can affect the efficiency, precision, and the properties of the manufactured additive. Tontawi has made a study by using Taguchi method and RSM optimization of printing process parameters, which is layer thickness, temperatures, and rest angles. Made a comparison between Taguchi method and RSM method. For Taguchi method, the optimal result for layer thickness, temperatures, and rest angle is 0.15 millimeters, 195 degrees Celsius with 0 degree of rest angles. RSM method, layer thickness, temperatures, and rest angles for the optimal result is 0.05 millimeters, 199.8 degrees Celsius with 45.1 degree respectively. So, the comparison, RSM method is the best between Taguchi and RSM. Wu stated that layer height influenced the efficiency of printing process. With optimal layer height of 0.14 millimeters, the printing time is the shortest. Past research has gained optimal result for layer height, shell thickness, infill density, and printing speed by using DOE of Taguchi method. Cottrell said that by using design of experiment DOE, infill, layer thickness, and nozzle diameter can be optimized to improve the printing part of the PLA. Layer height. Past research studied that layer height has a relationship with print time test that can affect the duration of the printing time. When the layer height is small, the printing time will become longer and vice versa. They also made a study that layer height can affect the compressive strength of the printed part. For nozzle speed, they use a process parameter which is nozzle speed to find optimization value of the parameters. By using the model design of the cube created by 3D-CAD, the optimal result for the nozzle speed is 70 millimeters per second. The dimensional accuracy can be increased by increasing the nozzle speed alongside with increasing layer thickness and decreasing density. For temperature, with the result obtained by previous research, they stated that by having extrusion temperature at 220 degrees Celsius, the values of the tensile strength, yield tensile strength, and modulus elasticity was at its best values. Fernandez also did a water absorption test where the best extrusion temperature was at 200 degrees Celsius, as it does absorb water at the very least amount. Next, problem statement. So the problem statement is, what is the optimization of 3D printing process parameters for PLA-HA filament? Number 2, what is the method to find the optimal result for the printing process parameters? And number 3, what is the experiment to validate the optimal result? We go to objective. For the objective, it is to identify the 3D printing process parameters and to validate the optimal data with experimental result. For scope and limitation. For the filament, there is the scope and limitation. Since the filament that are going to be used is PLA-HA composite materials, so the optimization of the 3D printing process parameters only limited to those filaments. Process parameters. We only choose 3D printing process parameters that have to be optimized, which is layer height, temperatures, and nozzle speed. And for the methodology, for the optimization method, it will only focus on the RSM's design of experiment. The output will be tested with mechanical test, which is compression test. For methodology, this is the flowchart of the methodology. First, we start with PLA-HA filament production. By using fused deposition machine, which is FDM, filament will be produced. The filament size will be 1.75 millimeters. So that is the filament size of the PLA-HA filament. Then we'll go to design of experiment, which is DOE. RSM will be used for the optimization. 3 process parameters were chosen, which is layer height, nozzle speed, and temperature. So this is the experimental data for process parameters. We have layer height, nozzle speed, and temperature. This is to run the RSM method. Number 3, to test the output. To find the optimal result from the experiment, the output needs to be tested using physical testing and mechanical testing performing the experiment. The first physical testing is scanning electron microscope, which is SEM. From SEM, we can get the result of the quality of the printed part in terms of the physical features in the surface topography and composition of PLA-HA. For surface roughness, it has relation with layer height. With minimization of the surface roughness, it is an indicator of the optimal result that can be gained. For compression testing, which is the mechanical testing, by using printed part standard of ASTM D695, it will be tested under compression testing to see the mechanical properties of the printed part. So this is the specimen, standard specimen for compression testing. And the last one is to validate experimental result. To validate the result for the optimal parameters, design expert software will be used for the validation. Using the software, optimization of the printing process parameters can be obtained after validated with experiment data. Expected result. So this is expected result. This is the expected result that we can get from the past research, which is the layer height and printing time. At the end of the study, the optimum printing process parameters will be obtained by using design expert software. But for the preliminary result, we find correlation between the layer height and the build time with the output, which is the surface roughness. By increasing the layer height, the printing time will become faster, while the surface roughness will become larger. To decrease the surface roughness, the layer height should increase, but the printing time will become longer. So this is the expected result. With that, I end my presentation of an optimization of 3D printing process parameters with PLA and composite materials by using design of experiment. Thank you.